It's literally everywhere. It powers our phones, our homes, our entire world. But let's be honest, most of us don't really know how it actually works. Well, today we're going to change that. We are going to decode the hidden rules that run everything, from a tiny little spark to a massive bolt of lightning. So, let's get into it.
Come on, you've done this, right? You rub a balloon on your head and poof, suddenly it's defying gravity, just hanging out on the wall like it's magic. But what if I told you it has absolutely nothing to do with magic? In fact, that little party trick is the very first clue in a scientific mystery we're about to solve together.
That's right. That little shock you get from a metal doorknob, the way your socks cling to your shirt right out of the dryer, it all follows a very strict, very predictable set of rules. Our mission today is to crack that code and finally understand the science behind these invisible forces.
All right, to start cracking this code, we need to think small. I mean, really small. We're about to dive into the secret world of charge, the invisible foundation that all of electricity is built on.
So the first piece of the puzzle is something called static electricity. You can literally think of it as electricity that's just sitting still. It's at rest. It all happens when you get an imbalance of these tiny charged particles, like when those little electrons decide to jump ship from your hair onto the balloon.
And this, well, this is the heart of the matter. Everything in the universe is made of atoms, right? And atoms have positive protons and negative electrons. But here is the absolute key, the most important part. Only the tiny little electrons can actually move around. So, if an object grabs some extra electrons, it becomes negative. If it loses some, it becomes positive. That's it. That's the whole game.
And once an object is charged, things get, well, dramatic. It's a constant push-pull dance, and it follows one unbreakable law of the universe. Like charges, so two positives or two negatives, always push each other away. They repel. And opposite charges, they pull toward each other. They attract. This one simple idea governs everything else we're going to talk about.
You know, this all leads to a really elegant and fundamental law, the conservation of charge. Just think of it like this. Electricity isn't magic. It's more like bookkeeping. You can't just create charge out of thin air, and you can't destroy it. All those electrons are just being moved from one place to another, and that's exactly what makes electricity so predictable.
So we know these little charges can move, but how they move and how easily depends entirely on what they're trying to move through. This brings us to the masters of the flow, the materials that either let charge zip right through or stop it dead in its tracks.
Basically, all materials fall into two main camps. On one team, you've got conductors, like copper and other metals. For electrons, these materials are like a wide-open superhighway. On the other team, you have insulators, think rubber and plastic. They hold on to their electrons for dear life, acting like a giant brick wall that stops the flow. This is exactly why your metal car keys won't hold a static charge, but a plastic comb definitely will.
So, how do we get things charged up in the first place? Well, there are three main methods. First up is friction. That's our balloon example, just rubbing two things together. Then there's conduction, which is as simple as it sounds. You just touch a charged object to a neutral one. But this third way, induction, that's where things get really weird and interesting.
Yep, you heard me right. With induction, you don't actually have to touch anything. By simply bringing a charged object near a neutral one, you can use its invisible force field to make the charges inside that second object rearrange themselves. It's a perfect example of action at a distance. It's proof that electricity has this invisible aura of influence that goes way beyond what we can actually see or touch.
Okay, so we've decoded the basic rules for all the small stuff. Now, let's scale things way up. We're going from tiny sparks on a doorknob to the unbelievable power of a lightning strike, and maybe even some of the hidden dangers lurking in your own home.
So get this, lightning is basically just nature's ultimate static shock. All that rubbing and friction between ice and water in the clouds builds up a colossal negative charge at the bottom. Then, through induction, that action at a distance thing, it forces the ground below it to become positive. When that electrical tension gets to be too much, zap! A massive, giant spark jumps to close the gap, and that's what we call lightning.
So how on earth do we protect ourselves from that kind of raw power? It's actually really clever. We use the rules of electricity against itself. A lightning rod is just a simple piece of metal, a great conductor, that basically offers the lightning a much easier, safer path to travel. It's like building an express lane for all that energy to go straight into the ground, completely bypassing the building.
Now, let's bring it all back down from the clouds and into our homes, where the dangers are a bit more subtle. You've got overloading,
That's when you plug way too many things into one outlet, causing the wires to get dangerously hot. And then there's a short circuit, which is even more sudden. That's when electricity takes a dangerous shortcut it's not supposed to, creating a massive, instant surge of power.
So, you might be wondering, if all this potential danger is all around us, why aren't our houses constantly catching fire? It's because our homes have this amazing, hidden safety system built right in, designed specifically to tame the current.
It pretty much all starts with 3 wires. You can think of it just like plumbing. The live wire is the pipe that brings the electricity in. The neutral wire is the drain that takes it away and completes the circuit. And the earth wire, well, that's the emergency overflow pipe. It's the unsung hero, the lifesaver.
And these wires work together with our silent guardians. A fuse is like the ultimate team player. It's a tiny wire that literally melts and sacrifices itself to break the circuit if the power gets too high. A circuit breaker is like a modern, reusable fuse. It's just a switch that trips automatically. And that earth wire, our hero, if there's ever a problem, it gives any leaking electricity a safe escape route, right into the ground, protecting you from a nasty shock.
So, when you step back and look at the whole picture, it all connects. From that little static shock you get from a shopping cart to the incredibly complex safety grade built into your walls, none of it is random. It's all one big, elegant system that is governed by a clear, consistent set of rules.
And that really is the ultimate takeaway here. Once you understand the logic, once you know the rules, electricity stops being this chaotic, scary force. It becomes what it truly is, a predictable, manageable, and incredibly powerful tool that we get to use every single day. The code is cracked.